So we have a problem in module 2 about PCA, which was also asked in model question paper. So now we'll be solving this problem. So see, they have given data points. These are nothing but vectors. Okay. So you can add these two vectors, like this and this will be added, and this will be added. So we will be taking it like that. I mean, not added, it will be combined together to form one x. So let this be a, we'll say x1 is equals to 2 and 6, and x2 is equals to 1 7, and we are combining these two vectors, calling it as capital X or just x, which is 2 1 6 7. So you understood, right? We are naming this two and then we are just adding this. So what you have to do, remove this two, like this right bracket, this level, remove, it becomes a matrix. Now you have to find the mean of this matrix. What's the mean of this matrix? It's very simple. You just have to add these two values, add each row and divide by 2, and divide by the number of numbers present. So mu is equals to, see, 2 plus 1 I have added. Okay, then here 6 plus 7 I have added. 2 plus 1 is 3, 3 by 2 is 1.5, then 6 plus 7 is 13, 13 divided by 2 is 6.5. So then I'll write here 1.5, 6.5. You got the value. So you got this value. This is, what is this, 1x2, like one column and two rows, like that. Then what you have to do, you have to find the x centers, in the sense, let me just write here x center. Simple, you just have to subtract these two values from this, in the sense, first 2 will be subtracted from this, and 1 will be subtracted from this. So since we have here x equals to 2, is simple. So let me just write x center is equals to 2 minus 1.5, 1 minus 1.5, here 6 minus 6.5, the below value, 7 minus 6.5. Okay, what it will be? 2 minus 1.5 is positive plus 0.5, 1 minus 1.5 is minus 0.5, 6 minus 6.5, it is minus 0.5, and 7 minus 6.5 is positive 0.5. So you got the x center matrix. See, this diagonal is negative, this diagonal is positive. Now we have to find the covariance, COV, they say, right? It is equals to 1 by n minus 1 into, see, x center into x transpose center. Transpose is what, rows and columns. Okay, don't worry about that. Transpose, it will be same. So now you will be confused about what is the n value. N value is nothing but 2. So number of features here, how many features are there? x1, x2, 2 features, right? So here n is equals to number of feature, which is nothing but just 2. So 1 divided by 2 minus 1, that is nothing but into, here see, x center is what, 0.5 minus 0.5 minus 0.5 and then 0.5. Okay, again into transpose of this also will be the same itself. There won't be any changes. If there was inverse, for in inverse the rows and columns interchange, and even if you do so, see, transpose, that's what, transpose and inverse are same. This will become like this, but here both are same. See, even if you interchange, that's what is happening here. It's not changing, because even if you take the inverse of transpose, the value remains same. See, I'll write here. So 0.5 and minus 0.5 is a row, it will become column. What will become? 0.5 minus 0.5. This will come here. See, it's the same. So now it will become 1 into same. So now we have to multiply this row into this column, like that. So it will be 0.5 into 0.5, that is 0.25, plus minus 0.5 into minus 0.5 is plus 0.5. So 0.5 plus 0.25 as it is. So this is the one value. Then you have to multiply this into this. So here 0.5 into minus 0.5, that is minus 0.25. It will be plus here, but we have, okay, plus, always it is plus, that's the basic rule. Now we have minus 0.5 to 0.5, that is minus 0.25. Okay, here now we have to multiply this row with this column. So it is minus 0. See, very simple. Write this same thing over here because that's the same thing, and then write this here 0. Okay, now we will add this value 0.25. 0.25 is again 0.5, minus 0.25 minus 0.5 again minus 0.5. Here see, plus into minus is minus, plus into minus is minus, so again it's minus 0.5, and here it's just 0.5. okay, so you got the covariance, what to say, I mean this here. So this is equals to XCOV. You can rewrite it over here to find, like, now we have to find the eigen values for this. To if you want to find the eigen values, you just have to see do this as this x where is this x sorry, not that matrix, x curve. Here we have this x center or this x curve. You have to take this, subtract this with lambda I. I is nothing but that identity matrix 1 0 0 1. okay, whatever is equals to 0. This is the basic equations. So now what we have to do, we have to write the same 0.5 minus 0.5. okay, so thank god I saw it on time. This was not visible. okay, so see, x minus lambda I, and here minus 0.5, and here is just 0.5. I wrote the this what to say, x curve first, then I have to subtract lambda into 1 0 0 1. This should be equal to 0. Now what happens, I'll write it this side so that I can do two calculations. I have to write this as it is just to explain you. Don't do direct solving and stuff. You write the steps so that it will be now minus lambda 0 0 lambda is equal to 0. It's very simple now. Now how it becomes 0.5 minus lambda minus 0.5 here as it is, and here minus 0.5 as it is, here 0.5 minus lambda. This is equals to 0. okay, since we got these values, now what we can do, we can convert this thing. okay, so we have to take mod of this. I forgot to mention the mod itself. okay, so now remember, I'll keep it over here, you can see, then I'll solve it down. Now this thing we will take it as what to say, squares. okay, we just have to take this in one line. So this cross multiplication, so what will happen, 0.5 minus lambda the whole square, and here we'll have minus itself, minus 0.5 into minus 0.5 is plus 0.5, so that is 0.5 the whole square. okay, now we have that formula that a minus b whole square is to a square minus b. So I'll write here a square minus b square minus 2ab, right? This is visible. okay, so 0.5 square plus lambda square minus 2 into 0.5 into okay, I'll write like this, 2 into 0.5 into lambda 2ab minus 2ab, and here you have minus 0.5 square. So plus 0.5 square and minus 0.5 square will get cancelled. Then 2 into 0.5 is 1. okay, so we'll be having lambda okay is equals to 0. I have to put here is equals to 0. So remaining is lambda square minus lambda is equals to 0. Now here you have to take common. So lambda square minus lambda is there, you can take lambda as common. So what will you have, lambda minus 1 I, okay, is equals to 0. So now you have to do two things. One, this bracket will go to the denominator of 0, so lambda is equals to 0 by lambda minus 1, or lambda minus 1 is equals to 0 divided by lambda. Here what it is equals to 0. Here lambda minus 1 is equals to 0, lambda is equals to 1 will go there, plus 1. So you got the values lambda is equals to 0 and 1. Okay, so now these are your eigen values. Okay, now we have to use these eigenvalues to get eigenvectors. Very simple. The same way how we had multiplied this, now we will just multiply that with see here adjustment lambda I V inverse. So here now don't take the value as lambda. Okay, we have the value, so we have two values, so we'll consider one value first. This is equals to 0. Okay, so now lambda is equals to 1. What it will be? See, 0.5 minus 0.5 here, minus 0.5 here, just 0.5. I will write this minus, if since this is 1 into identity matrix is the same itself, right? So 1 0 0 1, it's the same, so there is no changes. This bracket is there over here. Okay, now this whole thing is multiplied to this v1 and v2. What is this v1? We will see now. So it's simple, it is 0.5 minus 1 here, minus 0.5 as it is, minus 0.5 as it is here, 0.5 minus 1 into v1 v2. This is equals to 0.5 minus 1 is minus 0.5, so all the values will become minus here, minus 0.5 minus 0.5 minus 0.5 v1 v2 equals to 0. Now you have to multiply this into this into this. So minus 0.5 into v1, I'll write as it is, plus it will become minus 0.5 v2. Okay, then here minus 0.5 v1 minus 0.5 v2. So this is equals to 0. So both, now we can assign this individual as 0 0. So that will be your equation 1 and equation 2. Like we can just take like that. So you see, minus 0.5 into v1 minus 0.5 v2 is equals to 0. So now minus 0.5 we can take it as common. So what will be remaining? v1 minus v2, okay, which is equals to 0. Then again I have to, one second, if I take here comma, it will be positive, minus minus. Yeah, that's the same. So I'll send this 0.5 down, which is nothing but v1 minus v2 is equals to 0. Now v1 is equals to v2. Okay, so we got one value like this. I think something is wrong over here. Just a second. Instead of taking, if I take minus 0.5 common, here it will be plus. Yeah, understood. See, I am taking 0.5 minus 0.5 as common, right? So if I take minus outside, there should be plus here. If I keep minus here, so minus 0.5 into minus v will become plus 0.5 into v2. So it has to be plus here. So v1 is equals to minus v2. Okay, so we can also write this as v1 divided by v2 is equals to minus 1 divided by 1. Or you can also write 1 divided by minus 1, because the actual answer at the end will be getting same, right? So that's not a problem. So now you can say the eigenvector, eigenvector for eigenvalue lambda is equals to 1 is v1 v2 is equals to 1 minus 1. Similarly, you have to do the same now, taking lambda is equals to 0. When lambda is equals to 0, 0 into what to say, identity matrix, whole things become 0. So you will have direct 0.5 minus 0.5, here minus 0.5, and this 0.5 as it is, into directly you will do v1 v2. This will be equal to 0.5 v1, this is positive now, then minus 0.5 v2, same thing here. Now here minus 0.5 v1 plus 0.5 v2. You can take anything, we will take this one. So this is 3, this is 4, both are is equals to 0, since this thing was equals to 0. So I will take this one, 0.5 v1 minus 0.5 v2 is equals to 0. So now what I will do, I will send this side. 0.5 v1 is equals to 0.5 v2, this cancel, v1 is equals to v2, then I can write v1 divided by v2 is equals to 1 by 1. So eigenvector v1 v2 for lambda is equals to 0 is nothing but 1 1, both are positive. In that one will be negative. Okay, so we got eigenvectors as well. Now you have to do normalization of eigenvectors. If they have asked in the question, you might what to say, do it like solving the eigen what to say, not eigen, normalization. But if they have not asked for normalization, then no need to do, but still we have to check the what to say, all the possible things. Okay, just a second. So now you got the eigenvectors, you can keep at 1 or minus 1, this is also same, or minus 1 or 1. So the first thing is or type, right? Then you have 1 1, both positive. Now you have to go for what to say, if you combine this, I'll call a variable a is equals to, now I'll take what to say, I'll combine both the eigenvectors into one, that will become minus 1 1, here for positive 1 1. Since you got the eigenvectors, now you will be taking combining them into one matrix, and then you have to perform normalization. So basically you have to do normalization. Formula is like x1 divided by x1 square plus x2 square, but this will be in the root. Same, x2 is equals x2, see, x1 square plus x2 square, this will be in root, this whole thing is 1. So now you will take your x1 as a positive 1, x2 as a negative. If you are taking this vector, this will be x1, this will be x2. If you are considering this column x1 x2, it will be like that. So you have to do even now, like you are calculating separate. You can either do both together or you can do separately, both are same. So if I take directly, I can apply for both the things. So it will be like, see, minus 1 divided by, so minus 1 the whole square is plus 1, plus 1 the whole square is 1 under the root. Same way, 1 divided by 1 plus 1, here 1 divided by 1 plus 1 under the root, 1 divided by 1 plus 1. This is equals to minus 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2. That's the normalization. This is the formula for that. The thing you will write is one second, that en is equals to. Okay, once the normalization is done, you have to do the transform data. It's very simple. Y is equals to, so since we have called a is equals to this side, don't forget to put this bracket. Y is equals to a into, you just have to multiply what is that, x centered matrix. Where is the x centered matrix? You have here, right? 0.5 minus that one, so you have to multiply that, minus 1 root 2 1 root 2 1 by root 2 1 by root 2 into 0.5 minus 0.5 okay. I'll keep the values here so that you can see, and I'll solve it over here. So minus 1 by root 2 into 0.5, this column into this row into this column. So first value into this row first value, then usually it is plus, but since we have here minus, so I'll write minus 1 by root 2 into 0.5. okay, this value is like, it should be like this. Okay, then again here to here it will be, here it should come here. Okay, so 1 2 3 4, right? It should be a 2 cross 2 matrix, so a result also will be 2 cross 2 minus this into this column. So minus into minus become plus, so 1 by root 2 into 0.5 plus 1 by root 2 into 0.5. okay, this is one value. Calculate and add it. Same way here I'll just write directly 0.5 divided by root 2, this row into this column. Here plus will come, but since we have minus here, I'll directly write minus 0.5 divided by root 2. Here minus 0.5 divided by root 2 plus 0.5 divided by root 2. You have to add these values. If you multiply, see, let's do it. So here minus 0.5 divided by root 2 minus 0, I'll do it over here. 0.5 whenever you subtract, if there are two matrices to be subtracted, so it will be root 2, right? Shit. So you have to cross multiply and do. If you cross multiply, it will be, see, what to say, so this thing is whole minus, this will go here, and this you have to multiply. If you are, what to say, multiplying the denominator, root 2 into root 2 will become 2, then you will be having minus 0.5 into root 2 minus 0.5 into root 2. okay, if you take minus this as common, you will be having root 2. Again, if you just solve it, you will get what to say, you can write it as root 2 into root 2 as well. Here root 2 into root 2, but whatever you do, the subtraction, what to say, it will be one will be 0, the other will be, you will be having getting some values. okay, so if you take, where is that thing, if you take minus above, one second, let me just so if you are taking this minus 1 above, so actually it's better if you consider this minus 1 above, the value which you will get will be 1 over here. okay, this will be minus 1 okay, plus of minus, I'll keep, if I leave it here, 0.5 plus minus 0.5 root 2, so we'll be having minus 0.5 into root 2 plus there is no space, minus 0.5 into root 2. okay, so you can take root 2 as common for this, then you will be having, if you take root 2 as common, you will be having minus 0.5 minus 0.5, and down you will be having root 2 into root 2. I don't have the scientific calculator, or else it would be, way much easier, but no problem. We are doing right. So here this will get cancelled and have minus 1, right? Oh, see, simple things. I will do it again over here. See, minus 0.5 divided by root 2. here minus 0.5 divided by root 2. The thing is, if you are subtracting, you can multiply the denominator. So you will be having root 2 into root 2, and you just have to cross multiply. Root 2 into 0.5, I'll keep it minus. Then minus 0.5 into root 2. Now what I did, I took root 2 as common, then I'll have minus 0.5 minus 0.5 divided by root 2 into root 2. So here this is I'll cancel, it will become minus 1 divided by root 2. Okay. So I got here what? 1 minus 1 divided by root 2. Same way, if I try to solve it, here I'll get plus 1 divided by root 2. And here if I try to multiply this, so see here this is positive 0.5 root 2 minus negative. So this will get cancelled, this will get cancelled. So I'll have 0, 0. Remember one thing, here, where is that? Sorry. We took as minus 1 and 1. If you take 1 minus 1, this value will be ulta. So 0, 0 will be above, and minus 1 by root 2, it will come down like that. Okay, so once you do, this will be your that Y matrix. And now you have to, sometime in model question paper, they have asked just to solve this, but you should also mention like verify it by doing the reverse, PCA thing. How to do that is nothing but x is equals to A transpose into Y plus M. Okay, so here A transpose, what was our A? So you have to take transpose of this. That will be same. Okay, there won't be any changes. That will be equal to, see, minus 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2. Then we have to multiply this with y, minus 1 by root 2, 1 by root 2, 0, 0. Okay, and then plus m. What is your m? That is mean. Okay, 1.5, 6.5. If you calculate this, minus 1 by root 2 into minus 1 by root 2, that is plus 1 by 2. Okay, see, if multiply, right, minus root 2 into root 2 is plus, so 1 by 2, and plus here this into this 0. Same way, minus 1 by 2, this right side value, because minus 1 by root 2 into 1 by root 2 is nothing but minus of 1 by 2, that's it. Then this value 1 divided by root 2, so here 1 by minus 1 by root 2. Same way, this will be 0. If you multiply this with here, it will be plus 1 by 2. So then now you have to add 1.5 here, 6.5. This will be added for both of this. This will be added for both of this. Okay, if you do that, see, 1.5 divided by 1.5 divided by 1.2 divided 1.2 plus 1.5 is nothing but 2 divided by 2. That will sorry, 1.5 plus 1 is 3.5. Whatever, see, half is nothing but 0.5, right? So 0.5 plus 1.5 is nothing but 2. Then minus half, 1 will be reduced, it will be 1. Here minus half, 6.5, that will only be 6. Half plus 0.5, it will become 7. So what was the given question? It's here itself. See, 2167, we got it. So we have verified that this thing is correct, and it gives the right answers. You understood, right? So remember, you have to take x center. The formula is nothing but x minus mu. Capital X minus mu. Mean. Then covariance formula is here. Then this for x center. Okay, and then you have to get eigen values. This formula you have to take x co, what you got, minus eigen, this lambda into identity. See this value. Then you will come to here, you got the things. Then if you want to find eigenvector, this vector type, this you will multiply with that. you will get two equations. Solve any one equation, you will get one matrix. We got here either -1 by 1 or 1 divided by -1. Both are same. It's better if you take 1 divided by -1, because v1 v2 it's coming down, right, or whatever, both are fine. Once you get both the values, what you have to do, you have to combine both the vectors into one vector, that is a equals to this, and then you have to find the, what is this, normalization, yeah, en. Very simple. X1 x2 for this, x1 x2, like it's for like call. If you are doing for 2 cross 2, it will be x3 x4, that his will be like that. Simple, right? Either you can do separately for this, just add, you will get this value. Now you have to multiply this with x center, that is this wala, not this wala here. Then like that you will get the answer. I hope you understood. If you are still confused, just tell me, I'll explain once again properly.